All right, hey guys, welcome to the Introduction to Brushless Motors lab. In this lab, we're going to go over how you can use an Arduino to control the speed of a brushless motor. Now, this isn't a very complicated lab. As you can see, these are all the materials that we need. We have an Arduino Nano. We have our brushless motor that has been mounted on top of a little piece of aluminum. This isn't necessary. This is just makes it easy for us to handle it. And we have, last but not least, our ESC, or electronic speed controller. Now, you need an electronic speed controller to operate a brushless motor. You cannot simply hook up the leads from a brushless motor into a power supply. There needs to be very timely switching going on to power the brushless motor. And that can be done by sending a PWM signal from the Arduino Nano to the ESC, and then in turn the ESC will be controlling the brushless motor. Now, this brushless motor operates at 11.1 volts. This kind of motor is typically used in remote control airplanes or remote control cars. And so they typically use lithium-ion battery packs that are either 2S or 3S. A 3S lithium-ion battery pack is equivalent to around 11.1 volts. So we're going to be operating at 11.1 volts. And that's where you can see the power supply coming in here on the right. We have the positive lead right here and the grounded lead right here. And then off the screen, we have a power supply that is supplying 11.1 volts. And we have also made sure to current limit it around 2 amps. This ESC and this brushless motor can operate at very high amperage, which can get dangerous. So we're going to stay under 2 amps for now. If you are using a battery pack, you may be able to achieve a higher current draw. All right. So as you can see, there are 3 leads coming out of the brushless motor. We have a red wire, a black wire, and a blue wire. All 3 of those are going to the ESC. Now, if you want to switch the direction that the brushless motor is turning, all you have to do is change 2 out of the 3 leads. That will change the direction of the brushless motor. Coming out from the ESC, we have the power connection, as I said before, going to the power supply. And then there is a small ribbon here made up of 3 cables. It's made up of a brown, red, and yellow cable. The brown one is ground. The red one is around a 5-volt power supply. And the yellow one is the digital pin connection to the Arduino. So the brown will be connected to the grounded lead on the Arduino, and the yellow cable will be going directly to a digital pin on the Arduino. And we happen to be using digital pin number 3 right now. All right, so let's look at the code that we need to fire this thing up, and we'll see how it works. All right, hey guys, so we're gonna go over the code necessary to drive our brushless motor using the ESC. So to start out, we're going to include the servo library. Now, you'll see in a second why we're using servo. There is no such thing as a brushless motor library. We're actually going to be driving this using the servo library. So we're going to create an object of type servo called ESC1. You can call this whatever you'd like. We just call it ESC1. We're going to initialize some variables in this section, and as we go down further, you'll see why we're initializing them here. Now, you can see that there's a few other functions here before we do the setup function, but let's quickly jump down to the setup function first. So like usual, we're going to begin our serial communication at 9600 baud rate, and we're going to attach that digital pin coming from the ESC to a digital pin on the Arduino. So we're going to be attaching it to D3, pin D3. And then the ESC is actually internally programmed to function a certain way. So in order for the ESC to work, you have to quote-unquote arm the ESC. So in order to do that, you need to send it a pulse width that is basically 0, or something lower than the first command you want it to act upon. So in our case, we're going to call a function called arm, and as you see up here, there is a function called void arm. And what that does is it sets the speed equal to 0. And you can see we're using another function called setSpeed, which we define right here. I'll go over that in a second. So once we set the speed to 0, we're going to have a short delay. And it's, as I said, it's referring to this function called setSpeed, whose input is an integer. And what that does is we can write a PWM signal with a certain pulse width to the ESC. And this ESC, this particular ESC, is going to be expecting a pulse width somewhere in between 1100 microseconds and 1900 microseconds. So what this function does is it writes that PWM signal with the specified pulse width to the ESC. So we're using the command esc1.write microseconds and then a certain speed. So once we've armed the ESC, we're going to go into our main loop. And you can see here, this first part is just reading in the data that we're going to be typing into the serial monitor. So if there is something in the buffer, we're going to read it in character by character. And once we've reached the end line, parse time is going to become true. And then we can jump down to this if statement and start parsing our string. So in this case, the only thing that we're going to be sending it is a single integer. So we can directly convert the total string into an integer and assign it to a variable called brushless. And then we're going to immediately write that number to the function setSpeed, which we showed you up here. It's using the command write microseconds. And so once we've set that speed, we're going to have a short delay. And then we're going to print back to the serial monitor what we just sent to the ESC. So in this case, we're going to say brushless pulse width and with a colon, and then we're going to write whatever that command was that we sent it, and then microseconds. So the full thing that will be printed to the serial monitor will be brushless pulse width, colon, and then a number microseconds. All right, and then we're going to clear things up by setting parse time equal to false again so that we're ready to read in a new command. And we're going to clear the string total. So again, we can start reading in a new command whenever we enter something else into the serial monitor.